time with a new tool I've never used before, so I hope it works. Everybody can see me, and we are ready to have some fun with Eclipse HawkBit. Can you hear me? Probably a bit of feedback. The chat window is somewhere here. Excellent. So I think we will just wait 2-3 minutes till everybody joined. I myself was really spot on, just in time, ready for the webinar. So wait 2-3 minutes, and then we can dive right into Eclipse HawkBit. So let me prepare the slides. So do you see the slides now? Excellent. Works like a charm. Cool. Okay, so I would say let's wait 2-3 minutes more, and then we can start. Probably I already start to talk a bit about HawkBit, give you a little bit of introduction or background. We at Pragmatic Minds and Pragmatic Industries use HawkBit now productive since roughly a year now, I would say. We use it mostly for our digital cockpit, where we ship all updates via HawkBit. There are two reasons why the HawkBit architecture fits our needs we have pretty well. The Eclipse, we will just tell a bit more. Eclipse HawkBit is an open source project, of course. It's an Eclipse project, which is mainly developed by Bosch. So it's similar to Eclipse Vato and Eclipse Dito we already have seen here. Dominic Schabel, who is project lead for HawkBit, helped me a lot in the preparation of this webinar, but sadly cannot be here today to join us, so I will once again do the full webinar today. And yeah, so what else is there to know about HawkBit? I will try to explain you what exactly HawkBit does. It's a bit complicated to at first understand what HawkBit does, because it's only the server side. And initially, when I read about HawkBit, I was like, okay, cool, it solves my problems, it's an update. And then I was like, no, it does not solve my problem. It does not do the update. And in fact, HawkBit does everything except for the update. And why that is and how this works, I will show you later on, to give you really an overview of what HawkBit does and what HawkBit does not do. And hopefully everybody will understand it when we get there. Okay, now nearly 5 minutes over, and I think we are ready to really start with some content here. So first, stick with the title. Updates over the air made easy. Well, updates over the air is something which is a big term in automotive industry, but it will become an important topic in the industrial IoT area. When more and more software is shipped with machinery and is installed on plants, we will need to have a way to ship updates there. Currently, things run on air-gapped machines, on old Windows systems or even DOS systems, so no need for security updates. But as everything gets more and more connected, we will need to update the systems. So this is a need. So currently, we ship everything with an active updater just in case we might need it. Although the machine is still air-gapped, but someday someone will connect it, and then we will need to be ready for an update. Now, this is the roadmap we had. This is, in fact, the last webinar in this series. We have no concrete plans on how to commence, if we will still make those webinars from time to time. If there are requests or ideas, just contact us. Tell us what you liked and what you like to see, and then we will consider doing some of these webinars. From our perspective, this is kind of the end of the journey. As if you have your solution, then you need a way to update it. That's like the last thing you think about, probably. I usually had this slide, who am I? But I think I'm reasonably known now. So the title of the slide is now, what do I know about HawkBit? We use, as I said, we use HawkBit since 1 year in production. And although it was not myself who wrote all the code, in fact, 2 colleagues of mine who wrote nearly all the code, we have some experience with HawkBit. And we at Pragmatic Industries developed our own Python-based updater client, which does by default update Java applications. We considered making it open source. In fact, the only reason we haven't done it so far is because we were lacking the time. But with this client, you are out of the box ready to update your Java application by using HawkBit. How this works, I will tell later on a bit. And also an important feature here for such an update is it's nice to have a way for the updater to update itself, because there may be bugs in it. And if you ship hundreds of devices and you realize there's an issue with the updater, you better update the updater. This is an important feature that we are also able to update the update script in case there might be bugs. Okay, now we go on with the introduction to HawkBit. Already the first question. Excellent. If you have questions, just write them in the stream, and I will answer them. Usually, we have Java applications running on industrial PCs, so-called IPCs. So we do not have embedded applications. This would also work with HawkBit, but we have a regular Java full stack setup. So we have usually an IPC with Linux running on it, where we just have a JVM and a regular Java application running on it. There are, in fact, HawkBit client implementations for updating firmware, which is a bit different. Because I have to install custom bootloader and all that stuff. But we are really only on the OS level, so to say. We only update the stack. So all we have to do is to stop the application, copy the new application, and restart the application. So, but as in other webinars, I did not do all of the slides by myself, but in fact, Dominic Scharbe and his team shared his slides with us. On this picture, we may likely see Dominic. It's his profile picture. I think that's him, although we can't recognize him. And at this point, big thanks. I will show you the slides from Dominic and his team who are maintaining HawkBit and who are also maintaining the Bosch IoT rollouts, which is a managed service for Eclipse HawkBit, basically. So if you consider using HawkBit in scenarios and you don't want to host it on your own, there's simply this Bosch IoT rollouts, where you just get the managed instance of HawkBit with everything in there you need and can just connect your device and start. So I will now switch over my screen to the presentation listed here. So because it's an internal presentation, I think we cannot share it, but we will share the link. It's publicly available. But important disclaimer, so this is nothing I have done. So let me share my screen now. So you should see my screen now. So the topic, software updates in IoT, and in this context, of course, it's not only IoT, but it's IIoT. There is not so much difference between IoT and IIoT. Probably the most of the difference we see is that IoT, you usually have millions of devices that are pretty small. In our IIoT scenario, where a thing is a big machine, you don't have that many machines, but the software stack running on it is richer and therefore bigger. So this is, I would say, the most of the difference, that it's not a firmware update, which is 100 kilobytes that you ship to 10,000 of devices, but it's one big 100 megabyte software update that you ship to tens or hundreds of machines. That's it. But that's the only difference. So what does HawkBit do, or what is the aim of HawkBit? It's basically, here's an important word, a domain-independent backend solution. And this is what I said initially with this: HawkBit does everything except for the update. HawkBit is a backend for updates, not an end-to-end update solution, but a backend. You need some kind of front end to really perform the update, because HawkBit is domain independent. But it is tailored to roll out software updates for constrained edge devices, but of course also powerful and unconstrained devices that have some kind of connectivity in an IP-based network. It is based on Spring Boot, which makes it especially easy to customize it for yourself. It has a nice graphical user interface which works, but everything you can do in the user interface can also be done in via the management API, and even a bit more can be done via the management API, because sometimes you might want to use an API. You don't need an UI. Think about a CI server that, whenever it builds a release, already always registers it as an update. So no need to do it by hand for the developers, but just use the management API and do it automatically. So a bit of the motivation, and this is also interesting for everybody who considers these things. Updates basically you need in every software scenario. And especially in IoT scenarios, if you develop your own custom update mechanism, you do so many things twice or even more times. And in principle, the process of an update is pretty domain independent. Usually you have some kind of new artifacts, whatever that may be a script, maybe a binary. You may have rules, which device gets this binary. You may have rules what an installation is with this binary, but everything else is independent. You have to tell the device it should do an update. You have to provide it the artifact. You have to ask it if it's already started with the update, if it's already finished with the update, how the progress is. Sometimes you have forced updates where you say this is a crucial fix, update ASAP. Sometimes you have updates where you just say a new update is there, you should do the update. For example, you could show it to the user and say, okay, new update is available. Do you want to install it now or not? And all of this is domain independent. You may know this from your Office software, from the IDE. It's totally domain agnostic. You need some minimal device management, because you need some knowledge of the devices. For example, you only want to update a specific set of devices. Because you have a special update which impacts all devices with Bluetooth, but not the others, but because there's an error in the Bluetooth stack or something. So you need some kind of device management, but a small subset of what a really device management tool would offer. On the other hand, device management tools usually don't care about updates. And the update, there's a very simple update process, like, okay, everybody does an update, but the update process, especially when many devices are involved, should be done a bit more careful. And this is what HawkBit will do for you. This is the standard HawkBit overview you may find on the homepage to see how the internal architecture of HawkBit is set up. You see on the upper side, you see there's the management UI, and the management API, where you would, for example, if you have a fully integrated IoT business solution, you would never use the UI, but just the management API. And on the bottom part, you have two APIs, the Direct Device Integration API, DDI, and the Device Management Federation API, DMF, which works via messaging. And this is, for example, you could use other projects like Holo we presented here, plug it to the DMF, Device Management Federation API, and then get all the transport layers you want. The DDI, the Direct Device Integration API, is based on HTTP, simple HTTP connectivity whenever you have it available. Internally in HawkBit, you have three main parts. One is the device software repository containing metadata about devices and software. Then you have the artifact content repository, which is just the storage of the uploaded binary artifacts. And you have the software update and rollout management, which is a core process. How an update should process, which device gets an update, and all of those things. So going forward, now we start to dig deeper into the update process, and we see that updates are non-trivial. For example, a software update may not be a single file. Oftentimes, software is modular and contains of multiple artifacts or even multiple modules. And so first thing is HawkBit has this notion of a module which contains one or more files that always are together, like a README file that is shipped with jar or something. But these software modules are then completely contained. But then when you do it, then you assemble them in a distribution. And distribution is something that should be shipped at once. So for example, in example 4, you may have two types of devices out there, one with Bluetooth and one without. So usually you always have the same core bundle, but the device with Bluetooth also always get a Bluetooth driver bundle with them. So you would do two distributions out of it. One's the distribution without Bluetooth, one's the distribution with Bluetooth. But they have the same common module, for example. And then you do not only have to control that the Bluetooth distribution is only shipped to the Bluetooth device and the other only to the others, but then if you think about many devices, you have to really think about some kind of rollout management. The very first thing you want to do is, if you tell your devices, please do an update, then you have two possibilities: either push them the artifact or offer it for them to pull it. HawkBit uses always pull, which is a sensible decision in the IoT area, because usually the device cannot itself guarantee you that it's up or something, maybe in a tunnel, maybe offline. So whenever the device is online, it can ask for an update. Is there an update? And if there is one, it can say, okay, I want to download it. For example, you may want to download the update only when you are on Wi-Fi, not when you are on data roaming. So the device decides when to do certain things. This is the one reasoning. The second reasoning is, if the devices do it themselves and you just say, okay, here's a new update, then 10,000 devices may at once start to download the update and your infrastructure may break down. And then during the update process, when some devices report an error and say, okay, update doesn't work, but then it's already started and it's out there, then you're in a mess. So therefore, HawkBit has several mechanisms built in. For example, the deployment groups. So you can by yourself define by several measures how deployment groups should be done, and HawkBit does each groups at once, or at least starts them according to the rules you give it. That's the one thing it does. And the second thing is that inside each group, you can define certain triggers. One trigger is when to start the next update group, and the other trigger is when you should halt the whole rollout. So for example, in one group could be 100 devices, and if more than 5 devices report an error with the update, 5%, you say, okay, stop the complete rollout. This would reduce the amount of mess your rollout could cause, because you would see the error easily enough and stop the whole rollout, investigate, fix the problem, and restart the rollout. And this is really the core process that HawkBit covers. And here you see, this is totally domain agnostic. May it be updates for your computer, may it be updates for your smartwatch, mobile phone, whatever. You should always do it in some way like that to really have a fine-grained control of the update process and be able to handle things. And another thing that HawkBit also does is gives you fine-grained control over which devices you want to target with your update. So for example, you only want to update devices with software version 2.0, not those with 2.01, because 2.01 is already fine, but 2.0 may have a critical bug. So this is really the core process that HawkBit covers, and I will show a bit about that in some minutes. And as I said, it's for two reasons. One is to reduce the load and control by yourself how much load you and your backend can cover, but also be able to implement some kind of fail fast. If there's an issue, you want to be reported and to know about it, instead of having everything out there in the wild and no control. This is basically the end of the introduction from this presentation, and now we will switch back to now I will give you a short introduction to how HawkBit looks, the UI and stuff, and then we will look into the details of how an update works under the hood, and I prepared some example code to really have one update running with demo code on the client side. So I keep my screen shared. All I will do now is to open the terminal. And start a Docker container. So I hope everybody can see and read it. So the HawkBit team provides a Docker container, which makes it pretty easy and painless to start it up. So all I do is I start this command, and the container is starting up. Let's see. Oh, it's a good application, so it takes some time to start up. The Docker container they ship has an embedded H2 database, which of course you should not use in production, but you should use a separate database. But as it's all built on Spring Boot and JPA, you can pretty painlessly just swap database implementation of your taste. So when the server started up, we try to access the UI. Okay, finally it's started up on port 8080. The application itself is, as I said, based on Spring Boot and Vaadin as front end. The start credentials are just admin, as one would likely expect. So we sign in. Okay, so this is the default HawkBit UI. It has. Is it visible enough, or should I make it a bit bigger? The screen. Can you see it reasonably well? Okay, looks good. Excellent. So you have several tabs here on the side. In theory, the HawkBit system is multi-tenancy, but the default open source version only has a single tenant called default. So what you have there is deployment, where you decide which device gets a deployment, so gets an update. You have rollout, where you see all rollout campaigns. So you can do an ad hoc update for your device. Just say, okay, take the software version now. But you can also do a rollout where you give some kind of filters and say, okay, I want to do a rollout campaign over all devices that have specific attributes or properties. And this you can also do, therefore you use this target filter, so you define filters on device properties, where you say, okay, the device, the description of the device should be equal to whatever, or it should have specific attributes, software version, whatever you want. I will create a device in a minute and show you how this works. Then when you have this filter, you can do a rollout based on this filter. Then you have those distributions. As I said, a distribution is always combined of software modules. So you have to have several, or at least one software module, then you can package it to a distribution, and this can then be shipped in an update or a rollout. And last but not least, you need a way to upload your binaries. So you define software modules and then upload binaries here, artifacts, that are part of the software module. Well, there's also a configuration, but you may not need it. The only thing you could change here is a polling time. As I said, HawkBit is poll-based, so the client has to poll information from the HawkBit server frequently, at frequent times, and this is a configuration how often it should poll and when. If it not polls frequently enough, you mark the device as not in sync or offline, so to say. Everything else, I think we never touched so far. Okay, so we start. For a very simple theory, the first thing we need when you want to do a rollout is a device. So we just, which is called here a target, because it's a target for the update. So we just create a device, which I call my device. This is the internal ID. If you use the API, it can also be an auto-generated ID. So ideally, you just use some kind of UUID here or incrementing ID, and really use the name field here for the real name. And it's always bad to use to merge domain information with database internals, because this ID can never be changed, but this name can always be changed. Now this is my virtual device, and we could also enter description. Here's virtual. Okay, save. So now when I click on a device here, I see some information on the device here. I see the controller ID, I see the last poll. Well, the device doesn't exist, so of course it has never polled. And very important, a security token is auto-generated by the system, because of course we need some kind of access management. So each device has its own security token, which it needs to do the polling and also to get the updates. If you use the API, you can always also give your own security token. If not, the system auto-generates one for you. We have the description, of course, and then we have attributes. And attributes is something the device records. So I will show it later in a diagram. So your device can push some attributes. For example, the CPU serial number, or we, for example, also regularly push like the free space on the device. It's just something you can push on there, which comes from your device attributes. But the software version is something you should always push from the device. As it's good to have the software version the system thinks the device has, but it's better to have the version the device reports. So it says update pending because it waits for the device to send some. And when I would have devices here and I push the refresh button, then the next time the device polls and says, okay, do I have an update? It says, please send me your attributes, resend me your attributes. Then I see the name of the assigned distribution and version, the installed version, and I can give it some tags, and key values, which helps me to monitor my device. For example, as I said before, it has Bluetooth. I could set to has Bluetooth. I could set to false, and now I could say I could make a rollout campaign where I say, okay, all devices that have Bluetooth, yes or no. And I have some logs and this is as I said the metadata storage. The text is something I can just maintain here, which is easy to filter. I could, for example, the tag could be virtual, and now I could say now the device is a virtual device. Okay, so yes, tag is virtual now. Okay, so yes, now I could either do an update on based on virtual or on the key values I gave it. And with this key value store, you're totally flexible to really give it all, and also the attributes. So you can also control the rollouts by all those properties you see here. This is something we can ideally see here. Tag. You see tag here, and you see attribute here, and you see metadata here. Metadata dot has equals from. None may be found because I only have one with Bluetooth false. And if and the false here, okay, none are found. False. Now it should find my pre-registered device, and now I could store this filter, which is only the filter, not the concrete evaluation we did. Could give this filter a name, and then I could use it in the rollout campaign. I guess it just needs a bit to update the UI. Let's see. Okay, it finds my device, so I would say non-Bluetooth devices. And I would store this filter. And if I would have deploy a distribution, then I could just create a new rollout here. And as I said previously, you give it a distribution, you give it a custom target filter, non-Bluetooth devices, and you say if it's a forced update, a soft update, a time-forced update, only download, do not do the update. Should it start manually triggered? Should it automatically be scheduled in the night? And here you define the number of groups. This is the thing you have seen in the rollout process. The number of groups we will do the rollout in, the trigger threshold when the next one should start, the error threshold when we should stop the whole thing, and you either do it by percentage or you do it by count. And you can do some advanced definitions where you say, okay, the first group should, for example, be the devices in my lab. And only when I have no issues there, I go on. So here I can really manually control my groups, which might also make sense. For example, the first wave could be the devices I control, or it's not so important when they break, or when there may be an issue, because I can easily fix it. And can model it for each group, basically. So this is all the flexibility that rollout gives you, and via the API you can could even control it from another system, from an ERP system or something. You could do the groups by customer or whatever, because customer may complain when one of their devices is updated and the other one is not, and they will ask why is it updated. So each group could be device from one customer, then they might get updated at the same time. These are considerations that not the update system has to know, but you as the user have to know. Okay, now I can also show you a bit about the update. So I will now show you the process how to define an update. So first thing you need is we do the theory first. Let's do some theory and then go again to the funny example. So now we jump back to the presentation. Okay, so some more lectures. What I will show you now is one, more details on how this exact update process works, what the client has to do. And second, I wrote a very, very simple updater client, good weather Sunday updater client, which we will then use together with the HawkBit instance here to perform one update. So this is the situation where we are in now. I have a client device at the field where software runs in, and I have a binary here as a developer that I want to be shipped to replace the software as an add-on module or whatever. So this is the situation I'm in. And how do I do this now? And this device is not next to my office, but is somewhere in the world. And I do not have direct access to it. So what we have to do is we have some kind of updater client running on this device, which talks to our HawkBit and controls the update of the software. And this is what I meant by saying that HawkBit does everything except for the update. The updater client is not part of HawkBit. There are several implementations available, especially if it's not software but firmware you want to update. There are specific default protocols and there are bridges basically between HawkBit and those protocols, which then do everything like install a custom bootloader, register that the firmware at the bootloader, and at the next restart the firmware update is done and stuff like that. But for example, in our case, as we only want to update the Java software, the updater client, what the updater client has to do is specific to our software. So it has to stop the software. We usually use systemd, so it has to call systemd stop. Then it has to download the new binary, copy it over, and then we just reset a symlink to the new download binary, and then we have to do a systemd start, and start up the new version of the software. And if the new version of the software doesn't come up, then stop it again, reset the symlink to the previous version, start it up, and report an error. Now, this is also important knowledge. You do not just want to throw it out. So you really have to do a bit in the updater client. Therefore, in some cases where there are default update clients, it's good to use them because there's still a lot of knowledge involved here. But it depends on you how you handle these cases. Do you automatically jump back to the old version? Do you not jump back? Can you jump back? I mean, an update could even be a SQL file for a database migration. Nothing like that. It was just a SQL file that you insert or stuff like that. Okay, so how does the process now go on from here? And now comes the theory to what I will show you now soon in practice. So the thing we have to do with the binary is to upload it to HawkBit as an artifact, which is in a software module. And then we have to create a distribution based on this software module. And then we can just assign this distribution to our client device, which will trigger that the update client on its next poll gets the message to the update. And how will this work in theory? There is basically what HawkBit gives you is some kind of model how the update process is modeled on the back end. So you have to write your client according to this specification, so to say. So the first thing you learned already is this polling. You have this polling interval. So you just poll and say, okay, do you have something for me? I'm client with this name. This is my authentication. So do you have something for me? And then we already saw this attributes pending thing. And then HawkBit would say, yeah, just send me a config update. That's how HawkBit names it. And I will send a config update. And it also tells me, I want to get a poll from you the next time in 5 minutes. Okay, in 5 minutes, I want to call again and say, okay, do you have something for me? And it will say, yes, here's an update for you. And this update contains of these artifacts. Please download them. And then download the artifacts. Then I can report the status and can say, okay, I'm in this update. I downloaded the file, and the update is now 10% through. If I have a very complex update, it might make sense to report those information. If not, then just. And then I will. And then there's the screen. The screen line is really doing the update. This is your domain logic doing the update. Now you have a file, which you may know what it is, artifact, and now you come active and say, okay, stop the old version of the system, copy file over, start the daemon again. This is the update process, especially what you have to, what you really care about. And then you again report the status, or just report the end of the update and say, okay, update was successful, or the update failed. And then you are done, and basically that the loop starts again. And this is what we want to see now as an example, what I will show you now on the UI. And then, as I said, I wrote a very simple update client, which I will show you as a Python script, which does not everything, because you have to implement all those operations on the client side, but which just asks, is there something for me, which ignores the config requests, and which gets the notification, which can get the notification of an update, which does the download of the artifact, and then reports that it's finished. In fact, the update is just to print out the artifact. This is what is the update process for my thing. So this is, in theory, a complete stop of an update, but for example, I would not report on failure. And if I don't know, would not be able to print it out or something, or if the process cancels in the middle or something, I would not handle these cases. It's just to give you a nice and easy introduction. Okay, now going back to my screen, and so now we are back in HawkBit, and we define our software module. There are two kinds of module types: application and OS. That is a question. Yes, it can be. There is the management API, and you can do everything via the management API. So, for example, as you say on a push, when the thing is built, you could do it, or if you do not do the hardcore CI, or in the case of a new release, you could just register it. And in theory, you should even trigger an automated rollout. Yes, it can be totally automated. It's just a REST-based API. So you have two categories: application and OS. We will do an application. The module is my module, and you can give it a version, which may be whatever it may be. It's 1.0.0. The vendor is my suspicious attributes to help you with the management. Okay, so I have a module now, so I can upload a file now. I prepared a file, and as the update is to print it out, I prepared a file which is human readable. So I prepared a file which says, hello, I'm the update. So this is the update I want to do. I'll upload it now to the server repository. Usually you would upload a jar file. Okay, update is done, it's uploaded. Okay, nice. So I have a module now. Could also add readme or whatever, but I'm done. This module only consists of one file. Now I need to create a distribution. It's easy in this case as it consists of a single module. Again, apps only. Name is my distribution. And this distribution also has to have a version, which may be the same as the module or may not. But it's again 1.0. You could also say it requires some kind of migration step. So to say, okay, to get this version, you first need to install that version. Well, in this case, I don't need it. So I register distribution, and what I have to do now is to add this module to the distribution. I want to assign it? Yes, I want to assign it. Okay, nice. So I say this distribution here has several modules. What's wrong with the today? But all of them could also be automated. Okay, nice. So now there are two ways I could do it. I could either register a rollout campaign, which would be one way to do it. So I would just say, okay, I want to do a campaign. This is, I don't know, the daily update for today. I would say, okay, it's a distribution set. It's my distribution, version 1.0, and for the non-Bluetooth devices, total targets 1. It's the first update, do it ASAP. Number of groups should be 1. Okay, so now I could, let's see, Ah, yeah, exactly. So exactly. So here it just shows me the groups, group 1. Okay. So now I can save the whole thing, and now I have created a rollout, which is not yet started. I guess there's some issues with my browser. I don't know why. It will take some time to refresh. But now I have this rollout created that I could start at every point in time. Whenever, let's see, I'll just force reload the whole thing. Okay, so now, so here you see nice UI. So I have this rollout, which consists of several groups, but in my case, only one group. And I have some nice visualization about all the targets it would be. But the only thing is how much I did the drill down, so I see the group now. But the only thing that it will do when I press update now is when the device would request if there is an update, then it would say yes, there is one. So now we will look at some code to see the update side of things. So now I will move over to my IDE. Let me move over my IDE. This is some Python code that is publicly available. I will share the repo again as after every webinar. And now we will take a look at the code. So information we need to know is the tenant, which is always default. It's a controller ID and the secret. This is something I have to copy from my application. So I have my virtual details. So the controller ID is my device. Just copy it here. And the security token is this one here. This is something I have to share at installation time, or use something else that is already on the device, but some kind of pre-shared secret, so to say. Okay. Here I added several switches in my script to make it a bit more funny. Should download false. Should not start download. Should finish it now. Okay. So now I can simply run the program. I just start the program, and we will have a look what happens. There's some information printed out on the console you may not be able to read. So I'll make it a bit bigger. Please tell me if you can now read it. Is it readable, the console? Looks, yeah, should be. So the first thing I do is when the whole thing starts, I just trigger the controller endpoint with the controller ID, which basically gives out what the controller should do. And the response is a status code 1, which is good. And the payload that I get from the update server is this structure here. So it says, following, I should sleep now for 5 minutes. Okay, next time I have to ask for 5 minutes. And it gives me some links. And links are links or tasks, you could call it. And one thing is config data. So it says, please update your config data. This is the thing we've seen in UI. And use this link here. So I should do a post request against this link here with a JSON payload, giving it the config as a map, basically. This is something I skip here for brevity. So, but if I would do this now, this would not be shown the next time, as it already has a config, until I press this refresh button or after an update. So going back to the code, in here I just pass all the links and print them out and say, okay, the following links are found. This is like the task list for the device. So I should do config data, update config data to this endpoint. Okay, so now we will see what happens if I assign an update. So there are two ways to assign an update. One is to drag and drop it here, and ad hoc update. I'll just do it. And now it asks me what kind of update, like in the rollout. And as I said, forced update. I could even have a maintenance window, but don't want to use it here. Just say, okay, forced update. So now you see, one thing you see, that the device, initially it has a blue dot, and now it has a clock, which indicates it's in time. So I get it's connected, kind of. It always responds in time. And the second thing is an update is in progress. I will just do this really a bit bigger. Then we get some more information. This is not what I wanted to show, sorry. I want to update this thing here. This is the action history for this device. So it shows there's an update active. Okay, but the status, but there is no status yet because the device doesn't even know about update. So what I do now is I run the same script again, and we will see what it prints out now. Okay, it prints something else. Start is the same, but you see another link is here, deployment base, which contains another link, a link with some kind of random number, which means, okay, there's a deployment register for you, an update register for you, so please go here and get further information. So what I should see here now after refresh is that, well, as you see, you don't see anything. Excellent. So we should see, let's wait for you guys to refresh a second. So what we should see now is that at least our device knows about the update. UI not working that nicely. So the next thing we do in our code, this is here, if we see the deployment base in there, this means we should do an update. So I print out should do an update, and I do a get request on this link now, and it returns me this kind of JSON, which is like my the detailed command I should do. And I see here I have an ID. Every action has an UID basically. So this update has ID 1. Next update would have 2. It's unique. It's a deployment, and here I see some information. Download is forced, so I should do it ASAP. The update is forced, should do it ASAP. And here I see chunks, and the chunks consist of those modules. You see here, name is my module, and this module has artifacts, which goes up both lists, and I also get some hashes to verify the installation. Now see what I have here. Here. Okay, here you see it now. The symbol changed, so it's not longer this half-filled circle, but it's now an empty circle because I know I'm at the beginning of the update now. Okay, so you see here, initially we had no information, and now we saw the target retrieved update action and should do something. So now we know that the device knows. Okay, so what we should do now is to go down and download these files, which we did not do yet. But in theory, you should go to this artifact. This is the artifact I uploaded, and I should do the download. This is here, I go to all chunks and all artifacts, pretty simple code. And then I have the download link. But here I have this trigger should download to show you this, but I did not do it yet. So what I will do the next next step is I say it should download true. The next time I run this script, it again asks, oh, do I have to do something, update Cockpit service? Is like, yeah, still do the update, please. And now I perform the download. As you see, you should download. Yes, I choose a get request and get the download, and I print the content of the file. And this is what I said is the update process. So here you see I printed and hello, I'm the update. So I successfully got the file and I printed it. If we now look at the API again, it might take a bit to refresh. But then I would see here the information that the download was done. So we just refresh it. Probably browser related, I don't know. So now I look into the details, and now I see here this download icon. So the download was done. Excellent. So I know that the device has the file now. Now I could send updates and say, okay, I'm 10% through, I'm 20% through, and so on to tell about the updates. Or you can just say I'm finished or I'm failed. So the next thing we can do here now is if another branch, if I should finish, I either say it's a failure or a success. And then I set a specific payload version, a specific payload to a post endpoint, and that's it then, basically. Then the update is done. So what I say now, it should finish the update, true. So it should say the update was done. Update exception, true. So I will say the update finished, but it failed. The response will say, okay, update is closed, which means the process is so far done. But the result is it finished with a failure. So if I run this thing now again, okay, you see, the only thing I print out here is the code of the post response 200. So it was accepted by the server. So what I see now here, red. Then the server tells me, okay, this device, this update failed, which gives me the information. In my rollout campaign, the whole rollout campaign would be failed. I can just, for fun, we can just go here to this rollout campaign and just start a campaign. Now it started the campaign, right, waiting, and if I run the script now, rollout campaign is ready. Status green means campaign is done, but everything failed. Don't do that. So as time comes to an end, we finally will do a successful update to have a happy ending in here. So we do not return failure, but success, as we successfully printed everything out. So we are happy. Update exception we set to false. Now, otherwise there's nothing to respond to. And if I run the script now, I don't do anything because it didn't tell me to do an update. So no point. So interestingly, what you see, first 1 second, if you go here to the thing, what we see here now, which might be interesting, is we see all updates that have been done with this device. So not only the first one I triggered manually, but also the one which was done for during this rollout campaign. So this is nice, and I look sometimes here to just see the update history of a device. I have the whole update history. And as you see, for each of those updates, I also have the detailed information to see, okay, when did the download start, when did it finish? And here I see target reported closed with error. This is what I did. So, but no need to define a rollout. I just take that thing and push it here. So next trial to do an update, the third now with this device. But this time, update exception false, should be update true. This time we will have a happy ending. So we finally reported green, and this is what we see here. Finally, we have a successfully finished update. This is in very, very short, the minimal working example, I would say, of HawkBit. So you need at least some kind of script like that, which gets a notification, which regularly. I mean, what I'm missing here is a loop, which would just schedule the next call, of course. But then it's finished. So here you just ask if there is something to do for you, and if there's something to do the update, and then in the end report something. So this is like, in theory, the minimal thing you need to do. Then you only have a subset of the power. You, for example, you do not report progress, or you do not report config values, which would help managing the updates. But this is a minimal working example. Just start the local HawkBit, start this little script and play with it, and see what the server tells you and what you can respond and how the server reacts on it, basically. This is the very simple example, hands-on example I can give you. As I said, this Python file will be available on GitHub with a little README, how to work on it. You saw everything here, so you can go on, try it out yourself. This closes all I wanted to tell you about HawkBit, what it does and what it does not do. In fact, it does not do the update. It just tells you that you have to do an update. It's like your mother says, clean up your room. Cleaning up, you have to do for your own. But without your mother telling you, you would never clean up. So it's a good thing to have in place. So maybe this ends up the feature section of the talk, and I'll open for questions if there are any. Good question. What are available agents? Well, as I said, we have this Python agent, which just on a very high level can do an update. So it's 2 or 3 files and it gets pretty complex and messy, but in the end you can just write some Python code what to do. And I know for firmware there are several agents. I do not know their names, but they use some standard protocols from low-level programming, how they schedule the update. In fact, what I can do now is to Google it, basically. Eclipse HawkBit update point, and we'll find 2 or 3 GitHub repos, I think. There is, this is important, the Eclipse HARA project, which is a pretty young project where they want to collect exactly those agents. So we, in fact, already considered donating our Python update to the Eclipse HARA project. And the idea is really to collect those clients. But the only client that is out there in the wild is I don't know what's ROC or something. This protocol is called, I think, but I'm not 100% sure. So GitHub, second, with examples. Okay, no. Yeah, there's some others. Some Faint Line is there already, and a device simulator, but this is not what I want to show you. Yeah, 1 or 2 agents are out there, especially targeted at firmware, but I do not know them out of the box. Yeah, Rock, exactly. The Rock line there is. Thank you, Ayub. Okay, any other questions? There's a good question from Boris. Which PLC are supported by PLC Forex? In fact, I already considered that it would be pretty cool to have an integration to PLC so that you could do PLC updates over there. In fact, this is something we do not target that much in PLC Forex because of it terribly break things you don't want to get sued for. So yeah, currently there's no native integration between those 2 projects. So the best connection there is in our software, where we use PLC Forex-based software, which we manage by HawkBit, but there's no out-of-the-box support. Luca says Vago supports SV Update, so you could plug that together automatically. SV Update client with HawkBit and then with Vago. Another question is the device registration and the token. Can it be somehow automated? Yes, it can be. And in fact, we also automate it via the management API, so you can just register a new device via the management API, just say, okay, there's a new device with this ID and with this secret. So you can also set that the secret as you want it to be, because we usually do it the same way, and then place some kind of configuration file on the device which contains the secret. No, we did not handle security for it ourselves. Okay, sorry, cannot comment on that. But generally speaking, whenever you have questions or comments on HawkBit, there's a GitHub channel, there's a GitHub issue. There you find most of the core developers. We are just, I would say, advanced users, and this year's we present the focus on presenting a pipeline as how you could model your IoT pipeline end to end. Not only stuff that we do or stuff that we want to sell you or something. Yes, if there are no more questions, or if there are questions, then throw them out now, otherwise contact me afterwards. Generally speaking, if you like the series, then I'm happy to hear about it. If there are other topics that you think we could or should cover and tell you about, give you examples about, just ping me. If not, I thank everybody who made it today. I hope you learned a little bit and have some ideas how HawkBit could fit into your application, or probably not, because it's not end-to-end. You still have to do a bit yourself. If you are interested into the Python update that we wrote, just ping me. Probably we can together work out to get it open sourced. We are happy to share it with the world. Yeah, that's all from my side. Thanks everybody for watching. I have to find the button where to end this webinar. As I said, it's a new software. So, goodbye, everybody.